Look up at the night sky. In our galaxy alone, there are over 100 billion stars. Around them, billions of Earth-like planets. By all mathematical logic, the universe should be completely teeming with life, bustling with advanced civilizations, megastructures, and interstellar traffic. And yet, we hear absolutely nothing. It is a deafening, terrifying silence. The question isn't just, are we alone? The real question is, where is everybody? In 1950, physicist Enrico Fermi was walking to lunch with his colleagues when he suddenly blurted out that exact question. Where is everybody? This simple question birthed what we now call the Fermi Paradox. To understand why this is a paradox, you have to grasp the sheer, incomprehensible scale of the cosmos. The observable universe contains roughly 2 trillion galaxies. Let me put that into perspective. For every single grain of sand on every beach on Earth, there are about 10,000 stars out there. And we now know that planets are extremely common. A conservative estimate suggests there are about 40 billion Earth-sized planets orbiting in the habitable zones of Sun-like stars, just in our Milky Way galaxy alone. Let's assume life is incredibly rare. Let's say it only develops on 1 in a million of those planets. That would still mean there are tens of thousands of civilizations in our neighborhood. Furthermore, our solar system is relatively young at 4.5 billion years old. There are planetary systems out there billions of years older than ours. Imagine a civilization that had a 1 billion year head start on us. Look at how far human technology has come in just the last century. We went from horse-drawn carriages to splitting the atom and walking on the moon in less than a single human lifetime. Now imagine technology advancing for 1 million years, or 1 billion. A civilization that old should have colonized the entire galaxy by now. They should be harnessing the energy of entire stars using Dyson spheres, massive megastructures that would be visible to our telescopes. They should be sending out self-replicating probes to every corner of the Milky Way. Their presence should be so obvious, so overwhelmingly loud, that we couldn't ignore it even if we tried. But when we point our massive radio telescopes at the void, listening for a whisper, a signal, an anomaly, we find absolutely nothing. Just the cold, dead static of the cosmos. No radio waves. No alien superstructures blocking out starlight. No alien probes visiting our solar system. It makes no sense. The math says they should be everywhere. The evidence says we are completely alone. This is where the story takes a dark turn. Because to solve the Fermi paradox, scientists and philosophers had to come up with theories. And in 1996, an economist named Robin Hanson proposed a solution that is widely considered one of the most terrifying concepts in modern science. He called it the Great Filter. The theory suggests that there is a sequence of evolutionary steps that any life form must pass through to become a spacefaring, galaxy-colonizing civilization. The steps might look something like this. First, the right star system must form. Second, reproductive molecules like RNA must assemble from dead matter. Third, simple single-celled life must evolve. Fourth, complex multicellular life. Fifth, tool-using animals with big brains. Sixth, a civilization capable of exploring space. And finally, a galactic empire. The Great Filter theory argues that somewhere along this timeline, there's an evolutionary barrier, a step that is so impossibly difficult, so incredibly unlikely to overcome, that almost no species ever makes it past. It is a filter that catches almost everything. It wipes them out, or prevents them from ever evolving further. The terrifying part isn't just that the filter exists. The terrifying part is trying to figure out exactly where the filter is on our timeline. Because there are only 2 possibilities, and neither of them is particularly comforting. Possibility number 1. The Great Filter is behind us. If this is true, it means we have already survived the most dangerous hurdle in the universe. It means that one of the steps we've already taken was a freak mathematical accident. Maybe life itself. The jump from non-living chemicals to the first self-replicating cell is the filter. We haven't been able to replicate this process in a lab. And it might be so incredibly rare that Earth is the only place in the entire observable universe where it happened. Or maybe the filter was the jump from simple prokaryotic cells to complex eukaryotic cells. On Earth, simple cells existed for roughly 2 billion years before they made that jump. 2 billion years of absolute stagnation. It was a microscopic lottery that we happened to win. If the great filter is behind us, the implications are profound. It means humanity is special. We are the rare exception. We might be the very first civilization in the universe to reach this level of intelligence. We are alone, yes, but we have a wide-open galaxy waiting for us. We are the pioneers, the elders of the cosmos. This is the optimistic scenario. Possibility number 2. The great filter is ahead of us. If the filter is in our future, it means that life evolving to our level is completely normal. It happens all the time. Countless planets out there have seen the rise of intelligent, tool-using species who built cities, split the atom, and invented computers. But it also means that every single one of those civilizations hit a wall, and they died. If the filter is ahead of us, it means there's an inevitable, insurmountable barrier that destroys advanced civilizations before they can colonize the stars. And we're speeding right toward it. What could this future filter be? We don't have to look far to imagine it. As a civilization advances, its technology outpaces its biological evolution. We have the brains of Paleolithic hunter-gatherers, but the weapons of gods. The filter could be nuclear annihilation. The moment a species figures out how to harness immense energy, it also figures out how to destroy itself. We almost did it during the Cold War. The filter could be climate collapse. As an industrialized civilization grows, it exhausts its planet's resources and irreparably alters its atmosphere, boiling itself alive before it can escape to other worlds. The filter could be artificial intelligence. A civilization creates an intelligence far greater than its own, loses control, and is swiftly eradicated. Or maybe it's an engineered supervirus, created in a lab by accident or on purpose. Whatever it is, if the great filter is ahead of us, the universe isn't a nursery. It's a graveyard of thousands of dead civilizations who thought they were the center of the universe, right up until the moment they cease to exist. This brings us to a chilling conclusion about space exploration. Every time we send a rover to Mars, every time we scan the ice of Europa, we're looking for signs of life. We're hoping to find fossils, microbes, any indication that biology took hold somewhere else. But according to the Great Filter Theory, finding life on Mars would be the worst news in human history. Why? Because if we find simple life on Mars, it means the jump from non-life to life is easy. That filter is gone. If we find complex fossilized life, it means that jump is easy too. The more advanced the life we find out there, the more terrifying it becomes for us. Because it means the great filter isn't behind us. If life is common, then something in the future must be wiping it out. If we ever explore a distant star system and find the ruins of an ancient alien civilization that reached our level of technology and then mysteriously vanished, it would be a death sentence for humanity. It would mathematically prove that the filter is waiting for us. So, as we look up at the silent night sky, maybe we shouldn't be hoping to hear a voice calling out from the dark. Maybe the silence is a blessing. Maybe the silence is the only thing that gives us hope that we actually have a future. The universe is vast, cold, and full of mysteries that force us to question our very existence. If this journey into the terrifying silence of the cosmos left you questioning our place in the universe, make sure to hit that subscribe button. Because next time, we'll be exploring a mystery that's even closer to home and just as unsettling Until then, keep looking up, but be careful what you wish for.